graph looks like? And let's comment a lot about it. How will you draw an E par X graph? Like I think Samyukta was saying, like if you want to draw graphs, let me substitute some numbers and draw. Of course, good one, Samyukta. So E par X also you can do the same. Yeah. So what will be the best number for you to substitute?
0.
0. Very good. What is E par 0? It will be 1. Right. It's an exponential graph. And maybe if I substitute -1, what will happen?
Sir, no
1
values, I
by
guess.
V.
Yes, 1 by E. E value is approximately 2.718 people. So 1 by 2.718 will become like almost less than 0.5. It will be like something 0.4 something. If I put -2, it will become much more smaller. So it will become like very, very asymptotically close to the x-axis, slowly rising up, exponentially goes up. So I want you to put it in words, how this journey of E par X graph has been. Can you put this into your own words, how this journey of E par X graph has been? Journey.
Rags to riches.
Sorry.
So like English words or maths word?
Okay, well, however you want to say it, say it.
A slide.
I
Sir,
see.
infinitely increasing or something like that.
Increasing. Okay, it's continuously increasing. Yes. It's continuously increasing. Very good. Good point. Second point, it's defined for all real numbers. Defined for all the real numbers. So that means domain of E par X is all reals. What about range?
So minus infinity to
Really? Can you see any negative numbers getting created, Jeevish?
no, sir. It's 0 to
0 is not inclusive. So I'll use an open bracket for that because it will never reach 0. A positive base raised to any power will never become negative. Remember that. It will never become 0 also. This
yes,
will
sir.
always be greater than 0. It will go towards infinity. Infinity is also
Okay.
not a certain number to include. So I'll have you you have to put open brackets there as well. So see one single graph that I have drawn, but how many points I'm able to say. Next, since you said it's continuously increasing, so isn't it a one-to-one function? Isn't it one-to-one function? Have you heard of one-to-one function?
No, sir.
Two of
No.
x corresponds with one value
One-to-one
of
is like injection, people. One-to-one is like injection. So if suppose a doctor takes an old injection which he was giving it to another patient, will you accept it? No,
No,
right?
sir.
So injective is all like one-to-one. You can give only one injection to one person, unique injection to a unique person. So that means every input that I can see, it will give a unique output. That is what one-to-one function means. Every input has unique output. Every input has a unique output. That's what one-to-one function means. We call it in several names like injection, injective. Okay, now tell me, let's play with the graph. I love playing with graph. I expect you also fall in love with playing with the graph. This graph is going upward. Let's say I want to make this graph fall downward. What shall I do? You want to make this graph fall downward. Make it go towards negative infinity.
Sir,
make it -6.
Minus x. If I make it minus x, still it's a positive base.
sir,
Positive
E
base
whole
means
minus
Minus of EX.
minus of E par X.
exactly. You put a minus sign in the front. Whichever graph you multiply by a minus sign, it will just get mirror reflection. So graph will now come like this. Understood? Huh? If you put a minus sign before any graph, you will just see the graph getting reflected with respect to x-axis being the mirror. Don't forget this. X-axis will act as the mirror. So you can see that e power x. Can you see this graph e power x? It gets close to x-axis. You might see it's like merging with x-axis. It is not. The graph tool cannot show you that precision. You'll have to keep zooming till you see that. But if I put a minus sign in front of e power x, can you see the mirror reflection?
Yes, sir.
Great. So someone was talking about e power minus x. Can you think how will e power minus x work? I mean,
Reflected across y-axis.
exactly reflected across y-axis. E power minus x. Can you see that? That means whatever values was positive, I mean, the x value, it's just coming, it was coming at the positive x value. It's coming at the negative x value. Meaning, in this case, if I was putting e power 1, the answer is 2.718. Now, this will happen at x value being minus 1 only, no? Then only at x being minus 1 will become e power 1. That's why every point is being shifted with y-axis being the reflected. So this is a beautiful thing to ask you people. Now you're playing with graph beautifully. I can just ask you a question like e power x minus e power minus x equal to 0, and I can ask you the number of solutions. Until now, until this class, I believe you would be doing algebraic approach by writing this as e power x minus of 1 by e power x equal to 0. Then you would have written e power x the whole square minus 1 by e power x equal to 0. Then you would have done a square minus b square, all that drama. But now I believe the drama lies in just drawing the graphs. Because you can just check e power x graph should be equal to e power minus x graph. Correct? And in right away in front of you, this is e power x graph. And this is e power minus x graph. So what is the number of point of intersection, people?
1.
Only 1 point. No, so that means only one solution. Over. And where is that solution? At x equal to 0. Over.
No, sir.
So
At
understand
1.
how graphs can help us to identify this.
Yes, sir.
There is only one point where these two graphs are intersecting. No. So that will become the number of solutions. So whenever you see the keyword of number of solutions, try to understand there is going to be a graphical approach behind it. Understood this so far? Okay, let me make it a little more interesting for you. Let's say I'm going to ask you a question like e power x plus x square equal to 0. I'm asking you the number of solutions. Hope you understand what I'm actually expecting from you.
Sir, no solution.
Yeah, Ashi?
Sir, this is Samyukta. Is it no solution?
Yes, Samyukta, let's see that graphically. I can understand it's e power x equal to minus x square. I have to draw the graph of e power x and minus x square graph and see the number of point of intersection. You already have e power x being drawn. If I have to draw minus x square graph, y equal to minus x square, isn't it like x square equal to minus 4ay? The open downward parabola. They will have no solution. Correct, right? So slowly, let me ask you, maybe if you want to create at least one solution, have you heard about the power of lifting graphs? If you want to lift graphs, what you should be doing?
Change the constant.
Plus x square.
Exactly. Add a constant, the graph is lifted up. Or subtract the constant, the graph will be pulled downward. Okay. So now you see this is your minus x square graph, people. Correct? If you add a constant, let's say I want to pull it by 1 unit upward, put +1 to it, it will be pulled 1 unit upward. Right? So see the beauty then. Now you bring this E par X graph of yours. See, I'm creating questions. I have no textbook with me. I'm not looking at a textbook and reading question. I'm creating questions. I want you to think in that direction. Now when I put E par X and minus x square plus 1, see the number of solutions it had. It's having 2 solutions. So now that means instead of adding +1, maybe if I had added lesser constant, maybe my number of solutions will decrease. 0.1, I'm adding a 0.1. So still there are 2. Can you see that? There are 2 solutions. Now in exam, you will find people asking you the same question, but just written as E par X plus X square plus K equal to 0. Find the value of K such that this equation will have only one solution. Understood the question? They will
Yes,
ask you a question like saying E par X plus X square plus K equal to 0 has only one solution. If this has only one solution, find K. Okay, so for dealing with this, if you are good enough with understanding the E par X series, you might be playing with it safe. E par X. Have you heard about the series of E par X? No?
Sir,
yes.
I just
There was
heard
a
about
very
it, but I don't.
McLaurin's.
McLaren series, Taylor series. There was a very famous mathematician, McLaren as well as Taylor. They were working about changing every function into a polynomial function. So Taylor was working specifically with respect to 0, creating it. You can see how Taylor was working with it. This is a E par X graph. Taylor was trying to recreate this graph in terms of a polynomial. So x divided by 0 factorial. You can see that slowly he was trying to create it. He did all the experiments, but I'm not showing you all the experiments. So this was x power 0 he did. X power 0 by 0 factorial. X power 1 by 1 factorial plus x square by 2 factorial. So slowly you see something is happening to the graph he was creating. X power 3 by 3 factorial. So slowly you see what's happening to the graph.
Yes, sir.
Yes, sir.
Coinciding
Graph
with
he
the
was creating was slowly starting to merge with your E par X graph with respect to the 0 position. You see slowly the graph started to merge.
Yes, sir.
So whatever he believed was happening right away in front of his eyes. So he was able to slowly, but he believed that it has to be done infinite number of terms. But for us, the drama was happening only close to 0. So that is enough for us, right?
Yes.
For x square plus k to minus x square plus k or x square minus k to create solutions, you can just convert E par X graph to the expression like this. Then you start talking about the solutions it can create. Because they might ask you find k, but they'll give you literally like k as a value range as such. Because they cannot ask you for the exact value of k because you do not have that algebra enough to calculate it. They'll just give you the interval in which it could be possibly be present. Then k can lie in that interval. Clear, people? So we will be going in depth into all of this and explore maths. So we'll try to live in a mathematical world at least for the next 1 year. Okay. So you can keep thinking about this thing, what we have done. So I'll try to upload this class and give you the private link for the same. So maybe if you want to revisit something or listen to something again, so you can. So we have started with this functions chapter. So I have kind of said about a lot of terminologies. I was talking about range, domain, period, being continuous, like family members, a particular family having so many functions, how your mother feeds to each of that person without someone getting hospitalized. Recall all that. Okay, so we'll meet in the next class. Meanwhile, I'll also be posting some relevant questions based on what I have taught to you in today's session. Okay.
Yes.
Okay,
Sir,
thank
should
you all.
Thank you,
Yes,
sir.
Rishi?
Sir, should we answer them and send them to you, the question?
Yeah, you can WhatsApp me like what you are able to understand, what you are able to solve in that. I'll also help you with that by giving my hints, comments.
Thank you, sir.
Thank
So
you.
here, how do I use the Maclaurin series to find it?
So you kind of write the series like x bar 0 just 1, 0 factorial is 1. So 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial until this at least. And compare it to the right side. Look at the impact of your values because you understood that the roots if you are creating, it's only happening close to 0. That to left side of 0.
Yes, sir.
Check with respect to that. When I take values, then you will be given options. No, option A, B, C, D, K belonging to that particular interval. See if I'm taking values in that particular interval, what is happening.
Yes, sir.
And interestingly, it even takes calculus forms. If I say they'll be having only one solution, that means there is going to be a particular tangent at that point being drawn for both e power x graph as well as minus x square minus k graph. And that being a common tangent to both the graphs.
Yes,
Okay,
sir.
so
So,
much math. I don't want to dump every math in a single day. Okay, let's slowly bloom with that math. Okay, good night. Have your dinner.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you.
sir.
yes, sir.
Yes, thank you all.